5, and let's hop right back into it. Let's not waste any time here. So, came over here to do a quick test run on our front end, and I see that we have actually got a build error, and that actually has to do with this unit created action. It has to do with the call stuff not being found. So we've tried lots of different things that kind of work. I'm just going to try it one more time. I don't know why I feel like it's going to work, but let's try it one last time just to see, and it still doesn't work. Okay, so I believe it does a bunch of little magic here and there to make things work, which I'm okay with. So what we need to do is we need to actually change the reflect strategy map test around a little bit to be able to test it. So let's do it. Okay, so what we're going to do, we're going to do class, make sure you're going to ignore cover class, testable reflect strategy map extends strategy map. Strategy there, reflect strategy map. Now, I think what we can do is we're just going to need to override the init, and let's take a look at the class here real quick. So we need to essentially set this up, and what we need to do is we need to have it avoid creating the action, but I think we are already doing the object creator instance, so that's not going to work. Okay, so we're going to run into this problem frequently if we don't find a better solution for this. So one way we can do it is just not test for the unit create, but we're going to have that problem on unit move. Here we can actually send it out to do other things. We can grab the necro display and do something else with it, which I think that's what I'm going to do. Okay, so can't do that really effectively though. If we do this, okay, so we're going to go back to here, and we're going to do the mock unit created action. Let's sort of kind of defer this unit created action until find a better way I want to do this. So, oops, unit created action. So what we need to do is we're going to set this up. Here we're actually creating the necro game object. And there's a necro display. So let's do this. We're going to do public function create unit, and then we're going to, because this is eventually going to go away anyways, so what we're going to do is we're going to give it a looks like we're going to need more to this, looks like. So let's go look at the unit created. We're going to actually need a unit ID. We actually need like a unit type, which we don't have. So the unit ID is specific to the unique identifier that the player owns. Here we're actually going to need public var unit type. And so It's going to be appropriate, and unit type. And now we're going to do override create unit. We don't need this anymore. We don't need this. So unit created. So we have this create wizard, which is pretty specific to what we're doing. In fact, we could probably just do this. Could just do this. Create unit ID, and then unit type, unit created, unit type, and comma here. All right, so I think what we're going to do is we're going to put this here. I'm going to call this unit. And really, we just need this here. We don't need this. Unit is losing all meaning quickly right now. There we go. So let's look at the Necro game object. Extends a wizard game object, and that's just a game object. So now we could just cast this as a game object. Game object. Okay. Turn. And what we'll do is we'll pass the unit ID here, so unit type. Right now we're not doing anything with it, but it's ready to go when we're ready. And this is going to be unit created, unit ID. And we've got unit created position X, which will go here. Boom. Unit created position, whoa. Get rid of this. Position Y. And there we have it. So we've kind of updated this. And now we need to override create unit. And we're just going to return null. And now where's our mock at? Unit created action, mock unit created action, and that should do it. Not quite yet. We need to use, no, that should be right. It's not quite right, is it? So here, if not test, and if not test, and we're going to fix this up, else return null and cam. So actually we don't even need this anymore. Unit create action. Alright. still, oh, it's the necro display. So line 37. So first of all, it's saying unit game object. And world entity. We can't actually set the unique identifier by the interface. So what we'll need to do is we need to set this here. Var unit necro game object. Okay. And we'll need the unit ID, unit created, unit ID, and unit oh, I can do this. See if that does a trick. Getting closer. Line 39, unit display. And it's still going to be a problem. Ooh. Can we assign the display? Unit.display. Let's do this. There we go. In fact, I think we can actually do this. Will that actually work? No. Okay, so actually I need it. I actually need that. Okay, so there we go. So our tests are passing again, but now we need to update our server side to the game server. Should turn that down. And we're going to do handler output unit created, and we're going to add the unit type nil. And one thing that we need to do is identify what the order is real quick. Create unit. Darn it. Long button. Create unit created. So it comes after unit ID. Okay, so I've been consistent with that. So unit type. So now lib game server. I believe it was under the battle. Unit created. Okay, spawn unit. Here we go. We only need the unit type. Highly fine for now. So unit type. We'll just give it a random number. And that should keep things together. Okay, so let's, that should be fine. Okay, next game server start. and then okay, unit created action line 48, missing a semicolon. There we go. So we've kind of made a couple of improvements, kind of unexpected, but that's what we do. We just got to keep making it better. This build deck. Come on, build. All right. And we should be able to just click the screen. There they are. All right. And we can make it crash just as quickly. So it seems to be an issue with the double create. And so not really sure where that's coming from yet. So we're getting a unit created. It's happening somewhere in here. Valid character. So it's actually kind of important to understand why we're getting such things. So if we do cut the run, let's just try this again. So that's the connection. There's that. So it's actually getting there. And if I right click again, I believe this is because the game crashed. This is at something other, something different. So what I'm going to do is I'm actually just going to comment this part out and see if we can see if it goes away. If it goes away, it's pretty clear it's somewhere in there. The error is a little deceiving on this. And then we can actually handle this side too. And maybe we shouldn't yet. There we go. So that is the problem. See, I'm having a problem with that at all. So let's clean up this side. Clean up the server side first. So what's going on is we're getting a. Was trying to read from the game server socket acceptor. When it's trying to read here, and does the stream receive? See here, line 32. So yeah, right here when it's trying to receive the data, the socket is closed because the game has crashed. So what we need to do is we need to handle that, and in a better sense, we actually want to handle it on the socket server, I believe. That's where I want it to be handled. So when we get our accept client connected, I want to, oh no, that's fine. I want to, what's the key color here? What's going on? There we go. I want to, where's our client connected? We actually return OK in the PID. I think what I want to do is I actually want to receive it. Plot status. Status. And then here we can say monitor PID status def p monitor PID nil to nil. So that's where when it's the error case, and then monitor PID okay, PID. Let's make a pattern match on that. Do end. And want to take a look here on the Elixir, because monitors I don't play with nearly as much as I want or need or should or everything. So sometimes I need to refresh my memory. Let's go here. I think it's under process. Unlink. No. There we go. Monitor. There's the monitor. We need to monitor item. Okay, so we need to turn the monitor for reference. The need for monitor example inline by the compiler. Okay. So if I can remember right, is what I want it to do monitor. Okay, so the calling process starts monitoring the item given, it returns the monitor reference. So process monitor PID, that gives us monitor reference. Then what? So this is going to happen on the server. Handle info. Monitors or links. I definitely just want to monitor it. Let's just stick with that for now. Let's see what happens. And then we can handle that better when we're ready. So, actually I think I need to do a build. So that's that build. And here's the key to developer survival: plenty of water. If you want to make games for a long time, drink plenty of water. It's easy to forget. Come on. Right click. So, yeah, this is still failing. Might have to spend some time and sort of think about how I want to handle the monitor. So for now, we're just going to keep this. See if the tests don't fail. Okay, good. All right, so what I want to do is I want to get closer to having the game looking a little bit more like it did. So we need to move the unit. Now, one thing we don't have set up on our battle is a game loop. So let's go vi lib server battle. Okay, so here we're executing stuff, but really we want to probably pack it onto a queue and having something else pop it off the queue. So I'm probably going to change this from battle to command queue. In fact, let's just do that now. Let's just change this over to command queue. Okay. So here, when we don't need this open anymore, and here we're going to call this the command queue. Okay, and change this over to command queue. And I think I'm probably going to want to spend some time here pretty soon concentrating on making sure that we can actually debug through IEX better. But until then, so we're going to move lib game server battle to lib game server command q IEX. Okay, next test. Alright, so what it wants is the test game server socket acceptor test to use the right thing. So command Q, and we're going to call this command Q. I'm probably going to change this execute, I'm sure, too. And our tests are back. Okay, so we're going to store this into a queue, and then we're going to have our actual battle game loop doing things. So if we do lib game server, we're going to call this one the battle now. Call battles. Okay, so def module game server battle do end. Okay. So this is going to create, we're probably going to use the X actor gen server lib game server command Q. So this one we have one, I'm going to export, so yeah, this is going to be export command Q. So the Q is going to run on its own process, which we're going to need to, which we do link, so that's good. And then this one we're going to export as battle. So now we have two processes going on, and this one's probably going to turn into like more of an OTP application. This one's just sort of storing some execution stuff, storing the units. So right now we're storing stuff in here, but we're probably going to want to store this onto some sort of list. And then we use the battle to pop it off that list. So let's kind of move toward that. I also don't like this, what's going on here. So we can probably make a macro out of that as well. So we've got lots to fix and update. So now, here we're doing a couple of casts, responding units. So we probably want to set this over to the battle. Okay? So what we're going to do is we're going to def start, there's start link, and do the initial state. Not sure what we're going to do with the initial state yet. May not even need one. May not even need a gen server. Just thinking through it. So let's kind of think through this a little bit. Let's think this out. So what we're going to do, we're going to call this def, call this the game loop, right? And effectively we're just going to loop back. Now, we need to make sure that there's some time that happens in between each iteration, which would be effectively, I wonder if we can just set this as a constant. We'll call this loop time, and it's going to be 60 frames per second. 60, 1000 divided by 60. Not even sure it actually built that way. Huh, seems to not care. So, and then we're going to need our command queue. Alias command queue. So what's going to happen is we're going to process our actions. First of all, we're going to say we're going to need to get now, and then sleep for now minus time left. Oops, left. All right, so we're going to just sleep for, so if it takes, let's say it's about 19 milliseconds. So if it takes the entire 19 milliseconds, we're going to execute right away. If it takes like 10 milliseconds to do all the work, we have to wait 9 milliseconds to re-execute the loop so that we have a consistent loop. So what we're going to do is we need to get the now time from the VM, which I don't remember how to do. So Elixir get time, get timestamp. Okay, so we don't want current date or time. This is probably too excessive, because I think this is, this is like actual date time stuff. So get milliseconds. We don't really want all this stuff. Chronos versus milliseconds. Okay. Unix timestamp. Take a look at this. So, this is way excessive here. There we go. IX, OS, system, time. That seems reasonable. Divide by 1000. Or interesting. Floor time. Oh. Float. Float floor. There we go. Still returns as a float. See here, round. Is there an integer? Okay. It's not that big of a deal. Okay, so I think that's reasonable to have. So let's do that. So we're going to say that's our now. Now. We're going to process our actions. And then now we're going to do now. Let's see here. Timer, sleep. And just to make sure, I believe timer sleep is in milliseconds. Timer sleep. Yeah, that's definitely milliseconds. There we go. So, timer sleep. I'm going to say later. Why not? And so it's going to be later minus now. So that'll give us, let's see here, now, later minus now, and then we want to find how much time is left from there. And that looks like microseconds. Later minus now. That seems more reasonable. Okay, so and is that right? Million? Let's see. Later minus now. Okay. Million works. Okay, so now we have that. Is we need to figure out how much time is left from there. So it would be, theoretically say it's like, so we want to just subtract that. So loop time like that. And I think we do want to start the battle server under a process, and that's a given. In fact, we should probably just call it def start to end. And so and we want to supervise that separate. So let's do this. We're going to IEX-mix cannot set the transitive function macro. I believe it's line 18. Oh. Do it correctly. So we do game loop. Let's just do it first. Okay, so game loop, we're going to just print inspect loop time minus later minus now. Game server battle game loop. line 19 saying so we're just going to compile it here. So lib game server. This is going to be battle.ex. So that looks wrong. So let's see what I inspect. Inspect. Game server battle game loop. So that is definitely wrong. I don't technically need this. There we go. Got to change both of these. There we go. And now if we do loop time minus that. Game server battle game loop. And that looks much better. So let's see here. Well, let us actually sleep that amount of time. May not let us. Game server battle game loop. Yeah. So it needs to be an integer. Elixir float to integer. Okay. So we just call round. Round. Okay. Let's do this. Game server battle game loop. Cool. Seems to be okay with that. So there we have it. So now let's get cracking. We basically need to take out a ton of this stuff and put that into the queue. So while we're at it, we're going to do game loop, like that. And what else we're gonna do is, there's a couple of things I kind of like about making this a gen server. Is I want to be able to set some states that I don't want to keep asking our process for it. That's a lot of overhead. So right now we're doing this game loop. And it's calling itself recursively. And really what I want to do is I want to be able to send a message to the game loop if I wanted to pause it or something like that, and debug it and then like resume it. I have to think about that. In the meantime, let's get this out of here. So we have our command queue, and we effectively just need to rip a lot of this out of this and put it into this. Def process commands. Okay. So we shouldn't get much of a change out of this. The problem is we have a lot of tests wrapped around this. Oops. Test, game server, and we have the socket stream handler, we've got util state IO. So maybe we don't. We don't really have a command queue test. So command queue test XS. Test game server. Let's do that one. Command queue test, and we can keep the player model maybe. Let's see here. It'd be kind of nice to do some of this stuff here, but no, probably shouldn't. Okay, so we have player connect. Get our server, our process. It's essentially everything here. I think I'm going to give this one some thought, just because there's a lot to think about here. So we spawn the unit, create the player store. So if we don't, so right now we're storing the game state, player D and player. And really we just need a queue, we just need a list. So here we get player connect, which is the type in our command data. And I wonder if this will clean up a ton of this and make our test way simpler. We won't need all this mocking. This might simplify this a lot, actually. Command queue test, we don't need mock anymore. And do we even need the, I don't think we need a lot of this. We don't need the socket acceptor, we don't need the store, don't need the reader, don't need self, don't need player, don't need that. Okay. Yeah, this is pretty good. We won't need to do this conditional, I think. So let's this is the command queue start link command queue start link, and we'll just register this as we don't need to register it. And head. So now should store command data onto Q. So now alias game server command Q. That's typing for us. And then command Q execute. And we usually take the socket, but I'm not fully sure why yet. Oh, I see. So we could just wrap everything up in that. So what we can do, def struct game server command Q. No, we don't even need to do that. So we do socket command ID. It's going to be nil. Command ID is nil, and the command data is nil. So it's very simplified now. Now, command Q execute is going to take socket, chow, and it's going to take a command ID, chow, and it's going to take some command data, which is essentially that. Okay? Now we'll do command Q retrieve, like that. I would say get next, I guess. It's probably get next. This is going to be our command, and I'm going to call this our socket, and we're going to get our command data, socket, command data, head, get next, head, and that's all we need. Assert command socket equals a socket, assert command ID equals 1, assert command data is equal to command data. There we go. There's our test. Next test. And it breaks all kinds of things because it doesn't understand what's going on. Command Q is line 27. There we go. So there's our broken test. And what we're going to do is we're going to effectively get rid of this. But we don't want to lose it because we're going to need it. So I'm just going to quit out of here, and we're going to grab this stuff, and we're going to save it, and I'm going to edit lib, and sort of battle, put that there, def create layer, or layer connected, socket command ID command data view and edit lib game server command Q. I'm going to take this out, delete that. Battle, we don't want to lose this. Put. There we go. So we didn't lose any of that yet. And we're going to go back to command Q. Don't need this. Don't need this. Look how much of this we're cleaning up right now. So initial state is going to be a list now. And now we're going to take our command this is going to be our queued, UE, queued will be game server command Q struct, and we're going to put the socket, we're going to put the command ID, which is this, command ID, command ID, command ID, and then the command data, and we're basically out of time. So we're going to set our new state here. We're going to do the it's just the way it is, I guess. Gonna need to, well, the problem is if that's easier, or it's faster just to prepend it, the commands. But that requires us to reverse it on the other side and then pull them off. We'll have to test that later. So we'll do game state. In fact, I think we just do this because it's already a list. Oops. ++ queued. There we go. Def cast, or def call. Def call get next, and that's going to be state game state do end x actor and it's something about reply and something. Reply, I thought there was a reply and update for some reason. Set and reply. So we're going to get the next command, game state head, and then we're going to set and reply our new state, which is everything but the head, and our response is going to be next command. Undefined function new state. It's going to be game state. Kind of construct player that's under the battle. Where are you, battle? Guy live game server battle alias game server models there. Player connected alias game server handler. Is it handler? That's lib server handler output. Handler output player connected. Alias game server stage player store. Unit created, we missed one. Unit created. Sure, we're moving these around a bit. Okay, so undefined function execute. I think the problem is this. I don't think we actually need that. I think it knows how to figure it out. There we go, we did it. Alright, we've now moved this to a much cleaner situation here. Do one more test. Should return null nil if command q. PID. It's probably not necessary now because we don't need it, but okay, so we're going to do visual mode, yank, put, and we're going to do that. We don't need this. And we're going to do assert command is nil. Test. And exception was raised because the head where are we at here? Don't need that open. Here, game state. Def p next game state. So here next is next game state, and we're going to do if length game state is greater than 0, do else and game state head nil next game state Ugh, no. Enum count. Alright, we're way over. And that's a bummer. Undefined should return nil. Argument error. Oh, we got this backward, that's why. There we go. What? Oh, man. Actually, I think what we could do is head and tail. And what we can do is nil and nil. Yeah, do this. Head, tail. And this one we can return head. Darn, okay. Is greater than 1. So we can do when length game state is equal to 1. So when it's equal to 1, we're going to return game state head, and then the tail. Def p next game state when length game state is greater than 1. Do it's going to be game state head game state tail p next game state when length game state equal to 0 and nil that. Close. Should return nil if no command on Q. Alright, gotta go. Gotta go, gotta go, gotta go. Darn it. Can't stand it. Left-hand side is list. enum 0, 0, empty. IO inspect length game state. IO inspect head. Mix test game server command q test 30h. So the head length one state. So out of time here. 1, 1. Ooh. Tail. Inspect is 1. So it looks like if we did nil, interesting. But if we do make put to return no command or q should be able to add again the q. So we need to do this again. Put and then make cut paste. All right, next test. Yep, see? It is not doing it. And if we do this, why is this being such a pain? If I do nil there, that was weird. Okay. Test, server command q. Yeah. If I do this and do tail, that should break it. Should be able to add it again. IO inspect tail. I think we're just have to leave here. Yeah, I gotta get out of here. Alright, we'll solve this tomorrow. Alright, everybody. Happy coding. See you tomorrow. Let's do this.